Now that the data has been prepared for analysis, it's time to see what conclusions we can draw from the experiment. Imagine you observe that the treatment average is higher than the control average. How can we be sure this result wasn't random? In other words, how can we be sure that the difference we see in the test actually exists in the entire population? A randomized design experiment is analyzed using a test of means analysis. A test of means is a statistical calculation of whether the mean values of the treatment and control groups are the same. Or in other words, is there a statistical difference in the results or not? The first thing to look at is the target variable average for both the treatment and control groups. This will give us an idea about the magnitude of the impact by the treatment. Similar to linear regression, a test of means analysis includes a t-test, which gives you a p-value. Just like in linear regression, the p-value tells you the likelihood that the actual difference between the means is 0. Generally, if the p-value is below 0.05, indicating a confidence interval of 95%, the difference in means is considered statistically significant. Using a t-test is especially important when working with smaller data sets. Seemingly large differences in means are much more likely the result of random variation in small data sets. Let's take a look at an example.